Okay, hello, my name is Sairy, and I am going to be working on section 4.1, the related rates worksheet, problem number 1, which tells us that a satellite is moving in an elliptical orbit about a planet. The equation of its planar orbit is 3x squared plus 4y squared equal to 20. If the velocity of the satellite in the y direction is 10 when the y coordinate of the satellite is 2, what is the velocity in the x direction at that time? Okay, so that is what we are going to be solving. And we can always start off with what we already know, which is that the equation of the planar orbit is 3x squared plus 4y squared equal to 20. We know that the velocity, the rate of velocity in the y direction is 10. So here we can just write rate of velocity in the y direction. So at a specific time is 10, and we know that the rate of that we are going to be solving for the rate of velocity for the x direction at a specific time. So dx over dt, we know that we can use chain rule because we have two different functions here with two different variables. So yeah, as a first step, we're just going to differentiate using chain rule. We are going to differentiate with respect to x. With respect to t, sorry. So we have 3x squared plus 4y squared equal to 20. We know that if we differentiate this, we just simply get 6x. And then we multiply times our dx over dt, and then plus our 8y multiplied by dy over dt, and we know that 20 just differentiates to 0. So now we have our derivatives, and I like to simplify. So we're going to simplify our derivative here with respect to t. We can subtract 8y from one side. 8y multiplied by a dy over dt. We can subtract that and move it over to our right side, so it's going to be a negative. So negative 8y multiplied by derivative of y with respect to t. And then we can divide our 6x from both sides. So if we divide that, we just get dx over dy equal to negative 8y multiplied by dy over dt divided by our 6x. Okay, and then we have even numbers here, so we can simplify that even further. So dx, derivative of x with respect to t. Sorry, I think I made a mistake here. I wrote y instead of t. Is equal to negative 4y multiplied by, again, our dy. We just bring that down over dt, and then 3x. Okay. And then from here, we can start plugging in more of what we know and figure out our final answer. So once again, we are given the y-coordinate of the satellite is 2. And we again know that the rate of velocity dy in the direction of y is equal to 10. Okay, and then we simply plug that into what we simplified down here. So we can say the derivative of x with respect to t is equal to negative 4. Y, which in this case is 2, multiplied times 2 multiplied by the derivative of y with respect to t, which we know is 10. And in the bottom, we have 3, and we have x, which I almost forgot. We need to solve for x. So yeah, I'm going to do it down here. We're going to solve for x. So solve for dx over dt, and we simply do that by plugging in what we know. So we have 3x squared plus 4y squared equal to 20. We plug it into our original function. We know that we are solving for x. Sorry, we are not solving for dx of dt. We are solving for x for a single variable. So 3x squared plus 4y squared equal to 20 is what we will be solving with. We know that we can do simple substitution into this function and just solve for x. Our y is 2, so 2 squared equal to 20. And we get 8. 2 times 2 is 2 squared is 4, and then 4 times 4 is 16 equal to 20. 3x squared, and then we have 3x squared. 20 minus 16 is 4, and then we can divide to the 3 by both sides, so it's x squared 4 over 3. And then we need to remove the square root. So our answer is going to be x equal, let me see, x equal to plus or minus square root of 4 over 3. And I think we can simplify this a little bit further. Yeah, so square root of 4 is 2, plus or minus square root of 4 is 2 over 3. Square root of 3, because that can't be simplified further. So this is our x. So now we know that our x is equal to plus or minus plus or minus 2 square root of 3. I'm sorry for misspeaking. And we can plug that into here. We know that 3x would be the same as 3 multiplied by plus or minus 2 over square root of 3. And now we can just solve. Okay, so d of x over dt is then going to be equal to negative 4 times 2 times 10. So negative 4 times 2 is negative 8 times 10 is negative 80 over, we can actually just do plus or minus. So plus or minus, because we have the sign here, 80, and then if we multiply, we know 3 times 2 is 6, and then we would get a square root of 3. Okay, and then we can simplify that even further by rationalizing our denominator. So I'm gonna do it right here, 6. We rationalize by multiplying by the denominator, and we know that that would be 6 square root of 3 over 3, and that can be simplified. So instead we would have dx, the derivative of x with respect to t, is equal to plus or minus 80 over 6 divided by 3 is 2, and then we just have a square root of 3, and this can be simplified even further. So the derivative of x with respect to t is going to be equal to plus or minus 40 over square root of 3. And that is going to be our final answer. The velocity, this represents the velocity in the x direction. Of this moving satellite. Okay.